Hello, this is Ms. Nichols, and this video is on the circuit equations, two of them known as Ohm's Law and the power equation. And the essential question today is what relationships and equations predict the movement of charges and energy in a circuit? So if you're an engineer and you're building a circuit, there's really only two parts of the circuit that you can control, two variables that you can control. So these are the independent variables. The first is the voltage. And the voltage is determined by the batteries that are put in the circuit. So when you look at individual batteries, they have a voltage value on it that just depends on the chemicals that are inside of them. And if you pull out a regular round battery, most of those say 1.5 volts. That tells me that the chemical reaction inside that battery gives 1.5 joules of energy to every coulomb of electrons. So how would an engineer control the voltage in a circuit then if all batteries have the same voltage, or most of them do? Well, you could, of course, put multiple batteries in your circuit. That's going to change the voltage. Or you could pick one of those expensive batteries that has a different amount of voltage based on the fact that it has different chemicals inside. The second variable that you can control in a circuit is the resistance. And the devices or the loads that you put in the circuit have kind of like natural resistance values based on the wires that are inside of them that depend on the design of the device. So if you want to change the resistance, you can change the number of devices you have, or you could change the device itself, or you could add something called a regular resistor. You could add one of those funky little resistors that would change the resistance of the circuit just because that's its job. So the resistance in the circuit is controlled by the resistors. So this means that for my circuit variables, voltage and resistance are always going to be independent variables. In other words, their values depends on the stuff you put in the circuit, the way you build the circuit, and changing one of those things, like changing the battery out, does not affect the other one, the resistance. So there's no relationship between voltage and resistance. However, the other two variables, current and power, are actually the dependent variables. In other words, the values of these two variables depends entirely on the voltage or the batteries and the resistance of the circuit. So changing those two things affects the current and the power because those are dependent. Let's start by thinking about how would you change the current in a circuit and what relationships are going to be relevant when it comes to calculating current. So if you were wanting to increase the amount of current, increase the number of electrons every second that were flowing in a current, what could you change? Well, the first thing you could do is you could put more batteries in there, right? If you have more batteries, then more electrons every second are going to be able to be pushed through that wire. Since each battery provides a certain amount of voltage, more batteries means we're going to have more voltage, which then determines having more current because more of those electrons are deciding to move through the circuit. Hopefully, you're thinking right now, well, that's a relationship, specifically a linear relationship between current and voltage. So doubling the number of batteries is going to double the amount of current that you have in your circuit. The other thing you could do to control the current in a circuit is to muck around with your resistor. Change out the device that you have or add additional devices, as we mentioned before. If I replace a low resistance light bulb, an easy to get through light bulb, with a higher resistance light bulb, a harder to get through light bulb, the result is going to be that fewer electrons every second are going to be pushed through that circuit. If you can think of that as a harder test, if you've got a harder test, right, less kids are going to be choosing to take that test. Which means that current has an inverse relationship with resistance. The higher the resistance, the lower the current, or vice versa. This brings us to our first equation, which is known as Ohm's Law for the person that developed it. We know that current has a linear relationship with voltage, and we know that current has an inverse relationship with resistance. So hopefully you could make an equation for current. If you want to pause the video and do it yourself, that would be amazing. But if you want to watch me do it, here's what we get. I equals V over R, showing the linear relationship with voltage and the inverse relationship with resistance. The last dependent variable is electrical power. A reminder that power is the amount of energy that's changing every second, or you can think of it as the amount of energy that comes out of the battery every second, or the amount of energy that goes into the resistors every second. So obviously more power is going to mean we can make more stuff happen, more light, more sound, more toast, etc. every second. So thinking about how can we get more energy to come out of a device every second, there are two ways of doing that. So let's think about first, what would happen if more electrons every second were passing through the devices? Well, since each electron has energy in it or carries energy, if you put more current, more electrons every second, it should follow that that means there's going to be more power coming out of that resistor as well. That would be a linear relationship between current and power. The second variable is going to be voltage. So voltage is the amount of energy each electron had. So if each one of those electrons that goes through it carries more energy individually, that also means more energy is going to be deposited. So in other words, more voltage also makes more power. There's another linear relationship between voltage and power. Combine those two relationships and you can come up with the power equation for circuits. Two linear relationships, one with current and one with voltage. So that means that power is going to be equal to current times voltage. Before we move on from this slide, let's just take a minute and take a look at how the units work out. Remember that current is a coulomb every second. And if we take that current and multiply a coulomb every second times a joule, or times a volt, which is a joule per coulomb, you get coulomb joule per coulomb second. And if you cancel out those coulombs, you're left with a joule every second, which of course is a watt. So the units for this equation work out as well. Okay, we're done with this video. Please take a few minutes to revisit the essential question, which was, in a minute here, what relationships and equations predict the movement of charges and energy in a circuit? Thanks for watching.